So today we're going to focus on just graphically. So you're going to see weird graphs today. Okay, very bizarre. Some are just scattered plots, some are shapes, some have open circles, some have closed circles, some have arrows, some don't. And we're just going to practice finding the domain and range of these functions. Okay, we're going to do the front in class together, so 9 problems. And then on the back, you guys are going to do the back page, back of the note sheet as classwork/homework. So, again, it's super important to understand domain and range before we move on. So, first of all, let's review. Domain is the set of all x values. And range is the set of all y values. So when you do domain, you're looking at the x-axis. When you do the range, you're looking at the y-axis. They also ask us if it's a function or not. So to test if something is a function, what test can we use on a graph? Sam? Vertical line test. Now the first one, I know it didn't copy very well on my board, but it's better on your paper, I think. These are just like a set of ordered pairs, like just scatter plots. Okay, this is actually called a relation. Which is a set of ordered pairs. We probably learned that in chapter 1 forever ago. But if you just have a set of ordered pairs, you're not going to say the domain is all real numbers. And you're also not going to have an inequality because it doesn't go on forever and ever and ever. It's a finite number of dots. So you're actually just going to list. And we will use a brace to contain our list. So for the domain, we're thinking about the x-axis. So one of my points falls at -1, 2, 3. So this would be -3. The other point falls at -2, and I'm just focusing on this axis right now. Another point falls at +1, and the last point also falls at +1. You do not list that twice, just list it once. So the domain should be negative, oh, I missed one when I drew the line. I shouldn't do this, isn't it? There's also one over here, and that falls on 4. So comma 4. Now for the range, we're going to focus on the y-axis. And I would always start at the bottom of it, and then you just kind of go across to see what number. So the smallest number touches is at -4. Then there's a point at -2. Then there's a point at 0. There's one at 3. And there's one at 5. You will not always have the same number of elements in both the domain and range because sometimes they repeat and you only list it once. And then we would test, is this a function or not, using our vertical line test. What do we think? No. It would fail right here. Alright, the next one is actually a little geometry shape, looks like a pentagon. So the function is actually going like around and back. So it's a closed figure. So it doesn't have arrows going on forever and ever and ever in both directions. So there's 2 ways you can do your domain. Remember, we can use like our brackets or parentheses with our commas, smallest to largest. Or you can use your inequality symbols. It does not matter which one you do, but I think the majority of you will prefer the bracket parenthesis method. So let's focus on the x-axis for our domain. What's the smallest any of the values ever touch on the x-axis? Caleb? Negative what? 3. Right here is at -3. It actually touches there, so that means we would include a bracket. The largest it ever gets on the x-axis is at positive 3. Also put a bracket. Now if you want to do the inequality, it would be negative 3 is less than or equal to x is less than or equal to 3. These are the same things. I don't care which one you do. What do we think about the range, focusing on the y-axis? I think they could tell me what the range is. Ashley? Negative 4 to 3. Bracket. Very good. If you were doing the inequality, it would be negative 4 is less than or equal to y, which is less than or equal to 3. Is it a function? Do your vertical line test. That would fail here, fail a lot of places. So. All right, starting on number 3, you're going to see some open circles. Oh, Garrett? I use brackets for both. Oh, for number 1? Number 1 does not have a continuous line connected. It's just a random selection of points. So like, technically this is including negative 3, negative 2.9, negative 2.8, negative 2.7, negative 2.776. It's including like a lot of decimals in between there as well, because it's a connected line.
When do you use
The parenthesis would be when we have an open circle. Okay, so the parenthesis will be when it doesn't actually touch that number, but it gets really close to it. Also, sometimes, I don't know if we have any on here, but we'll learn about vertical and horizontal asymptotes, which is where they almost touch but don't. So the parenthesis is when it's not included. So it's kind of like a less than or greater than symbol, where it doesn't include that number. Good question. All right, now the next one we have this open circle, which the open circle means that this is not included. It gets really close to that number, but it doesn't actually contain that number. So when we're doing our domain, we're thinking again about our x-axis. Start at the smallest point, which is at negative 1, 2, 3, 4. So we'll have a parenthesis this time, because it doesn't include. Comma. What's the largest it ever goes on the x-axis? Awesome. Infinity, because of this little arrow tip, it's going on forever and ever and ever. Infinity always gets a parenthesis because we don't know what infinity is. It's not an actual number. It goes on forever and ever and ever, so it's not going to stop. All right, range. Switch gears, go to your y-axis. What's the smallest it ever touches on the y-axis? Well, at 1. It actually has closed dots and it has a line. Lines are a series of closed dots. So it touches at 1, so it'll be a bracket. And what do we think the largest it ever gets is? So, infinity is the arrow. Is this a function? Yes. Do your vertical line test. Okay. All right, next one we have a circle. Since there's no arrows, you're not going to have infinity involved, right? Because it's not going on forever. It is a fixed value. And I should say, also up here, let's jot this down. If you wanted to, you could say that x is greater than negative 4 instead of the parentheses and brackets. So jot that down. It would not be greater than or equal to because it doesn't touch there. So this is an alternate way to write it. And I like to show both because sometimes on the SAT, they give you one method versus the other, and I want you to be comfortable with viewing both of them. You only have to be able to write one of them on your own, whichever one you like. And this one would be y is greater than or equal to 1, if you were to write it as inequality. All right, so the next one is a circle. And in pre-calc, you'll actually learn the equation for a circle. Who thinks they could tell me our domain for this one? Again, focusing on our x-axis. The smallest point, look at the largest point. Sam? I think it only goes to negative 2. Yes. And then it also only goes to 2. How about our range? Jade.
Bracket 0, comma 4.
Good. Touches at 0, touches at 4. Is it a function? No. They're all going to be different, so like you can't just say, oh, it's always going to be this or always going to be that. And we have a whole mixture of these that you'll be practicing today. The next one, what type of function is this? What do we call this? Ashley? Linear. Linear should be the easiest one. What's the domain?
Infinity.
Good. Negative infinity to infinity. Or you could just put all real numbers if you want and be lazy. Right? Less writing. But you can also put negative infinity to positive infinity. There's no way to put an inequality. Well, I guess you could. But I probably would never write it that way. You could if you wanted to. And then this one obviously is a function. It's linear. Passes our vertical line test. We did these a long time ago. What type of function makes a v? Hint, there's a v in the word. I think.
Absolute.
Yes, this is an absolute value. So it'd be y equals the absolute value of x minus 1, 2, 3, 4, 5. If you were given the equation. Shifted down 5 from the transformations. All right, what do we think about the domain? Again, when you do domain, you're thinking about this axis only. Ignore the y, just think about the x. What's the smallest the x gets? What's the largest the x gets? What do we think? Someone I haven't heard from you today. Gary? Close. See how there's arrows going past that point? Yep. And it actually goes past this as well. For all real numbers. Now, if it didn't have the arrows and it stopped at 5, you'd be correct. How about our range? Range, we're going to focus on this axis. Perfect. Bracket -5 to positive infinity. And this would pass our vertical line test, so it's a yes. Why don't you guys try 7, 8, and 9, and then we'll go over them on the board. And then we might even, actually do 7 and 8. We'll do 9 together because it's different. So don't do 9. We'll do that together. Since it has the open circles, we'll do one of those. The domain for 7. Garrett? Yes. Remember, you also are allowed to put x is greater than or equal to 0 if you prefer. And our range. Lexi? All real numbers, or negative infinity to positive infinity. And it's definitely not a function, right? Fails the test. All right, now I saw the domain pretty good for 8, but the range, let's put a little star next to it because I saw some incorrect answers there. So the domain, again, focus only on your x-axis. Look at only this line. What's the smallest it ever goes? Negative infinity. Okay, it comes to -1. It has a closed circle on both of them, so it includes -1. And then it goes to all the way to positive infinity. So you can have all real numbers or negative infinity to positive infinity. Now, when we go to the y-axis, it actually only touches at 1. This is 1, 1, 1, 1, 1, 1, 1, 1, 1. And at 3. 3, 3, 3, 3, 3. So remember back in example 1, when you have a listing of just numbers, you don't have a continuous thing that's going from 1 to 3. and including everything in between, you will use braces and you'll just do a list. So you should have 1, 3. The braces are a listing of numbers. When you do parentheses or brackets, that's telling you you're including all the numbers in between them. You would not want to include 2 because the function never touches 2, nor does it touch 1.5 or 2.5 or any of those. So this is just a listing of numbers. The only two y values it ever touches are 1 and 3. And then this one, was it a function or not? No, it would fail only right here. All right, now put some stars on number 9. We have what's called a hole in the graph. Actually, we have 2 holes in the graph. So points that don't actually exist in the function. Right here and right here. So for domain, I saw a lot of you doing negative infinity to 2. Then we're working ahead. You're close, but you have to exclude this point. So what we're going to do is we're going to go piece by piece. We'll do this part first. So this would be negative infinity to negative 3. Will I put a parenthesis or a bracket on negative 3? Is it included or not? Abby? Nope. Parenthesis. Open circle means not included. It's like not an equal bar. All right, now what you have to do is you have to unite that with another set. So you put a little U for union. Or it also seems like an and. Okay. And we're going to include this set of numbers, which will go from negative 3, not including negative 3, to positive 2. Also not including positive 2, so you're going to have parentheses there. So what this allows us to do is skip over the negative 3 because it doesn't have a bracket and it doesn't have a bracket. The range is a little bit easier. We don't have to do it in pieces. Now the smallest that the y-axis ever touches is at negative 2. Now, some students will argue with me and tell me that I should have a parenthesis because there's an open circle. But do you see how there are a solid line with solid dots at negative 2? So the closed circle will trump an open circle. If there's both of them present, it does actually include that value. Okay? Now, the largest it ever gets, some students will tell me it stops at 1. But since this arrow is going on forever and ever and ever, it actually includes 1 and includes 2 and all the way up to infinity. And this one would be a function. All right, for the rest of class / tonight, you're going to do the back of this worksheet only, not the next page, just the very back. And it has a mixture of problems again. Some of them you may have to use the listing if there's only a couple numbers. Some of them you'll have to use brackets. Some of them you will have to use this union where you may have a hole in the graph. So if you guys want to move around and work with the front